Thanks for joining me again. We're looking at quadratic equations, and in this video we're going to focus on solving by factoring. And what does that mean? As a reminder, factoring is when we have a product of terms. So in this case we have an equation that equals 0, so we'll have a term a1 times a2 and so on equals 0. Now, because we have a quadratic equation, so we have a x squared factor, we anticipate that we'll have basically two terms, and they'll have the form x plus something, say q. So we'll have one term x plus q, and we'll have another term x plus p. And these two factors, when multiplied, should give us 0, like in the original equation here. Now, we can't always factor easily. So this method for solving a quadratic equation is not always the most useful, but when it works, it's really elegant and transparent to see the solutions. And that's why when you're given a problem and you're told to solve by factoring, you can solve in other methods, but it means that this particular equation can be solved fairly simply using factors. Now, what does that mean? How do we factor this equation into this form? Well, we have to figure out what Q and P are, right? That's our main goal. In order to do that, we basically equate these two equations. We say, well, if these equations are equivalent, then we can compare them and look at each term separately and compare. So what does that look like? Well, we're saying that x squared plus bx plus c equals 0. And that equals, on the other hand, also x plus q times x plus p. And again, we have these two linear terms, linear because we only have one power of x, because we know that we'll end up, once multiplying these two terms, with an x squared term. So let's do exactly that. Let's work on this right-hand side. So in order to multiply, we'll use, as usual, our distributive property, which basically says that we have to multiply every term in the first parentheses by every term in the second. Let's count out our 4 terms here. So we have x times x, right? That's our first term in red. Our second term will come from this first x multiplied by the second term in the second parenthesis, so that's p. So we have plus x times p. Then our third term here, which I'll show in green, will be q times x. And our final fourth term, which comes from q times p, is just q times p. Okay, so we have 4 terms because we've multiplied a two-term parentheses by another two-term parentheses. And we're saying that these two equations are equal, right? So if they are equal, each term in our variables should be equal as well. So we have here x squared equals, in red, we'll put x squared. Okay, that's our first term. What about our second term? Our second term is bx here, and in this equation here we have 2 terms. We have xp, plus qx, okay, which I wrote both in blue now. Now let's play with this a little. Let's again use the distributive property and pull out our x here so that we have x times p plus q. This is correct. We have x plus p plus x times q. So in this case we have our b here times x, but here we have p plus q times x. So what we would like is to find p and q, that their sum equals b. Okay, so that is one requirement of our two terms P and Q. What about our final term here? So we have C equals Q times P, right? This is the equivalent constant term that does not depend on the variable. So again, we have another requirement that Q times P equals C. What does this mean? It means that we have to find two numbers, Q and P. And these two numbers should add up to B, and their product should be equal to C. So if we have a quadratic equation with a certain B and a certain C, we can try to look for sets of numbers whose product is C, so factors of C that also add up to B. Let's look at an example so that we can understand how we use this better. So I'm going to leave these two requirements in our picture here, and let's look at the example x squared plus 3x minus 18 equals 0. Okay, so in this equation here, our b is equal to 3 and our c is equal to negative 18. What does this mean? It means that q plus p equal 3, right? Our q plus p, the terms that we want to get, x plus q times x plus p, right? We want that to be equal to that, equals 3, their addition, while their product equals negative 18. Now, what does it mean that a product is negative? Well, if we have two positive numbers, q and p, their product cannot be negative, right? Also, if we have two negative numbers, q and p, their product will be positive as well. So in this case, we know that either one, either q or p, have to be negative in order to get this negative product. Okay, now let's start looking at all the factors of C, which is negative 18. So let's take Q equals 1 and P equals negative 18. The product of these two numbers is definitely negative 18, but their addition, their sum, gives us negative 17. This is not a good solution. This does not work for us. Okay, what about Q equals 2? If Q equals 2, we have to take P equals negative 9, right? 2 times negative 9 will give us negative 18. So that's good in terms of our product. What about our sum? 2 plus negative 9 is negative 7. Negative 7 is not 3, so this is not correct. Okay, what's our next option? How about Q equals 3, right? 3 is a factor of negative 18, and the P that'll give the product is just negative 6, right? 3 times 6 is 18 with a negative sign because of the negative 6. 3 plus negative 6 give us negative 3. So we're close. We have the right number, but not the right sign. So this is still not the correct answer. What about Q equals 4? Q equals 4 is not a factor of 18, so it will not give us another whole number for P. So Q equals 4 does not work. What about Q equals 5? 5 is also not a factor of 18, so not good. So Q equals 6 is our next factor. So Q equals 6 will require that P equals negative 3, right? Because negative 3 times 6 is negative 18. What is 6 plus negative 3 add up to? It adds up to positive 3. Okay, so we finally found our two numbers, Q and P, which can factor our equation. So we're saying now that x squared plus 3x minus 18 can also be written as x plus 6 times x plus negative 3, which is minus 3, and that equals 0. Now, how is that helpful? Well, it's really very helpful because as a reminder for why we actually factor polynomial equations, what we like to do is we like to use the zero product property. So the zero product property means that if we have two numbers multiplied to equal 0, it means that at least one of those numbers has to be 0. Because if one of these numbers is not 0, then the other one has to be 0 in order to get the 0. That's just how 0 works. So in that case now, we can use this product here to solve the equation. Because we're saying either x plus 6 has to equal 0, or x minus 3 equals 0. And if one of them is equal to 0, we have solved our quadratic equation. So these are relatively easy equations now to solve. Let's subtract 6 from both sides of this left one. We get x equals negative 6. Or we can add 3 to both sides of this equation, and we get x equals 3. Again, we have to use these properties where we add or subtract to both sides of the equation. We can't do something to one side and not the other. So we have x equals 3 and x equals negative 6, and those are solutions to this first equation we started with. Now, you can check this, right, by substituting. So substitution is the way we check an equation. We take the solution and we substitute inside. And if you substitute x equals negative 6 or x equals 3, you'll get 0 for the value of this side of the equation. So this is how we use factoring to solve a quadratic equation. And we'll have another video that actually looks at a more general form of the quadratic equation, where we have an a times x squared plus bx plus c equals 0. And in this case, a will not be equal to 1. And that's a little bit more complicated, but we have an equally useful method for factoring when a does not equal 1. So if this video has been helpful, please press that like button. If you haven't seen the other videos in the quadratic equation playlist, please check them out. And thanks again for joining me.